So now we go for arithmetic progression. I'm sure you must have studied earlier, but let's recap. A sequence A1, A2, and so on, AN is called AP, is called arithmetic progression or sequence. Progression or sequence, in short, it is called AP. If, what's the definition? Recall, the difference of two successive terms is constant. Difference of any two successive terms, if you take any two successive terms, is equals to a constant. Is a constant. Then it is called which sequence? Arithmetic sequence or the progression. This minus this. What is the meaning of this? That is A2 minus A1. The next A3 minus A2 and so on. This should be a constant. This should be a constant. Then it is called arithmetic progression. Difference of any two successive terms should be constant. What is the meaning of this? That is, here if I start with the first term A, then the next term must be A plus something. So usually write with D. Now you say difference is D. The next term must be A plus 2D. Now you see the difference. It is A plus 2D minus A plus D. It is again D. So this is next will be A plus 3D and so on. Just by adding that D, you will get the next term of the sequence. Is an arithmetic progression, is an AP. Where what is the first term? Where first term equals to, first term, that is A1 equals to A. And the difference is sometimes called common difference here. So common difference equals to small d. So first term is A and the common difference is D. Successive terms, if you pick up, there you will find the common difference like this. If I take 2, then I'll add here 3. So 5, then I'll add 3. 8, then I'll add 3. 11, then I'll add 3, which is 14 and so on. So is an arithmetic progression. This is an AP. This is an arithmetic progression. You see, 5 minus 2, 3. 8 minus 5, 3. 11 minus 8, 3. So common difference is 3 here. So if you know first term, next term can be obtained by adding the common difference. That's what I've written. If you know second term, add 3. So you'll get the next term. If you know this, add 3. You'll get the next term and so on. So this is a general format of AP. Fine. So from this you can write nth term also. From this we can write nth term. So here the nth term of an AP, nth term, an equals to plus a is there everywhere. In second term you have 1, in third term you have 2, in fourth term you have 3. So here it is n minus 1d. You know it from 10th standard. This is the formula for nth term of arithmetic progression. Nth term, a plus n minus 1d. What is a? A1, first term. What is d? That is a common difference here. Fine. The first term of an arithmetic progression, that is a, common difference is d here. Then nth term formula is given by this, an equals to a plus n minus 1d. You know it. I'm sure you must have studied. Okay. What we have noted here, if you know the first term, you can get the next term by adding common difference. If you know second term, by adding d, you get the next term. If you know this, add d, you will get the next term. Just keep on adding a common difference. You will get the one by one terms of the sequence. Okay. So one is this. Now we want to write the sum of the n terms of the AP. The next we want to write sum of first n terms of an AP, n terms of arithmetic progression. We want to write this, right? That is, summation means S, how many terms? N terms. So we want to write A1 plus A2 up to AN. For which progression? Especially for arithmetic progression. And it can be derived. I'm not getting into that. I'll write directly. It is, n by 2, 2a plus n minus 1d. You know this formula again from 10th standard. What is this? This is the sum of the n terms of arithmetic progression. You also know that this you can rewrite like this also, n by 2, a plus n minus 1d. So it is a plus l. What is l there? Last term. That also last term. And what is a? Always it is a a1, which is first term of the arithmetic progression. So either you can use this or you can use this, whichever you want to use. So these are the two important formulas. Every arithmetic progression question, either you can solve by Sn or An, right? These two formulas are very important. An equals to a plus n minus 1d. For Sn, you can use this, n by 2 2a plus n minus 1d, or n by 2 a plus l, whichever you want to use. Any one of these two can be used depending upon the question and the data. You can use this. Fine. Now here something more we want to discuss. Up to this you have already studied. Now next point within this arithmetic progression is this arithmetic mean. We want to write this AM, arithmetic mean. Arithmetic mean we want to write. So what we do, we take the three numbers which are in arithmetic progression. So let A, big A, and I'll write small b, are in AP. We have chosen three numbers in arithmetic progression. Then this middle number is called AM of the other two numbers, right? Then this middle number A equals to, or is called let's write, is called arithmetic mean of small a and small b. This is called arithmetic mean of these two numbers, a middle number. Now if you use the concept of AP, this minus this equals to this minus this, difference is same. So therefore if you use that, you will get the A equals to A plus B by 2. Simple average. You see this difference, successive difference, big A minus small a equals to B minus A. Now just make A as a subject of the formula, I will get this. So arithmetic mean of two numbers which that's the average, A plus B by 2. For example, see 2, 4 and 6, they are in AP, in arithmetic progression. So 4, that is nothing but the arithmetic mean of which two numbers? 2 and 6. 2 plus 6, how much? 2 plus 6, 8 by 2, which is 4. Right? These three numbers are in AP. Middle number becomes the arithmetic mean of the other two numbers. One more if I write here. Let's write 6, 8 and 10 are in arithmetic progression, are in AP. You see this become arithmetic mean of these two. 6 plus 10, 16 by 2. So this is arithmetic mean of 6 and 10. That's a concept. That's what we have stated here. Okay, now we want to generalize this concept. Instead of here one number, we are going to insert many numbers. So let's write here. So that is we call n arithmetic means. We write here n arithmetic means. Arithmetic means. So what we do, we take two numbers and we put n numbers between them. So I have these two numbers, A and B. There we had just placed one number, A. Here I am going to put n numbers, A1, A2, and so on up to an. We are going to put this how many number? N numbers. A1, A2 up to an. These n numbers we are going to put in such a way that total, these are how many numbers? N plus 2 numbers is an arithmetic progression. This is an arithmetic progression. Between these two numbers A and B, you have placed these n numbers in such a way that total, these are how many numbers? N plus 2 forms an arithmetic progression. This forms which progression? Arithmetic progression. Then these are called n arithmetic means. These are the n numbers. These are called A1, A2. These are up to an are arithmetic means. Arithmetic means between A and B. Between A and B. These are the given two numbers. Now our main point is we want to get these A1, A2 up to n numbers. Now this is an AP, you know first term. So if I get the common difference, I can get this. First number plus the common difference will get the A1. So here in this case, the common difference, I'm not getting into the proof. Common difference in this case, that is D, which is given by this formula here. D equals to B minus A upon n plus 1, right? Which you need to remember. Why this? I'll not get into that, but just to keep in your mind, B minus A upon n plus 1. So you know common difference now? B minus A upon n plus 1. Fine. You know first term. So what is A1? That is the second term of this AP. So first term plus common difference. So A plus D. You know D from this. So we'll get the A1. Once you know A1, how do we get the A2? That is above term A1 plus again common difference. So we'll get this and so on. So whenever you want to get this n arithmetic means, just get the common difference and inductively keep on doing like this. Fine? I repeat, see entire procedure. What I've explained to you, let me repeat. See, you have started with two numbers A and B. You have placed how many numbers? N numbers between these two in such a way that total n plus 2 numbers forms an arithmetic progression. I want this middle n numbers, which are called n arithmetic means. So if I want A1, this is an AP. I know A, so if I get the common difference, I'll get the A1. In arithmetic progression, you know, if you have first term, then how do you get the common difference? In AP, if I have the first term, if I know D, I can get the second term. If I know second term, I know D, so I can get the third term and so on. So what I need to know? I need to know common difference. And common difference without proof will state this formula, B minus A upon n plus 1. Once you have D, you have A. So what is A1? A plus D. I have A1, I have D. So what is A2? A1 plus D and so on. This way you can find n arithmetic means. Like this, if I take one example, see, suppose I'll start with 2, which is small a. I want to put up 3 numbers, 1, 2, 3. Suppose I want 4, 6, 8. So I'll put 10. Okay. This is small a. This is small b as per above theory. I want to place 3 numbers between 2 and 10 such a way the total 5 numbers forms which progression? Arithmetic progression here. How many numbers I want to place? 3. So n is 3. Okay. That means 3 arithmetic means. Okay, so I need to know common difference. What is the common difference? B minus A upon n plus 1. B minus A means 10 minus 2, which is 8. 3 plus 1, which is 4. So your common difference is 2 now. Fine. I know first term. I know common difference. So what is my first arithmetic mean? A1. That is this. What is my A1? A1 is nothing but the A plus D. Okay, what is A? That is 2. What is D? Which is also 2. So the first arithmetic mean is 4 here. That's what you had expected. What is A2? That is the previous one plus the common difference, 4 plus D, which is obviously 6. What is A3? That is the previous one plus the common difference, which is plus 2, so 8. So 4, 6 and 8. These are the three means between 2 and 10. So 5 numbers form the arithmetic progression. Fine? Understood? Is clear? I'll write one more question just to clarify further. The question is, insert the 6 numbers between these two. This is the next question. Insert how many numbers? 6 numbers. So any 6 numbers between which two? Between 3 and 24. Between 3 and 24. Okay. So it's like this in the solution here. You have 3 here, given number 3, 1, 2, 3, 4, 5, 6, and this is 24. So this is A1 up to A6. Fine. What I need to know? Common difference. How many means I want to insert? 6. So n equals to 6. What is the formula for common difference? B minus A upon n plus 1. That is 24 minus 3 upon n plus 1, which is 7. 24 minus 1, how much? That is nothing but the 21. So common difference will be here. How much common difference? It will be 3. Fine. So therefore D is 3. Now I know D, so task become easy. What is A1? That is first term plus common difference. So 3 plus 3, which is 6. What is A2? Previous plus the common difference, 6 plus D, which is 9. Okay, now you can write easily. What is A3? It has to be 12. What is A4? It has to be 15. What is A5? It has to be how much? 18. What is A6? It has to be how much? 24. And A7, which is this, 24. So these are the 6 numbers. So 6 numbers are this, which are the 6 arithmetic means. Which one? 6, 9, middle numbers, not 3 and 24. Then 12, then 15, then 18 and 21. These are the 6 numbers between the given two numbers in such a way that total numbers forms the arithmetic progression. Fine. Exercise 9.2, first question, sum of odd integers from 1 to 2001. So here, that is, the sequence is this 1, then 3, then 5, and the last number is 2001. So here obviously common difference is 2, and so D is 2 here. Now, first term, the last term. You want the summation of all. So you need to know what is n. So you can use this formula if you want. A plus n minus 1 into D. N means last term here. A means 1. D means 2. You place here. So you will get number of terms is equal to, which is quite obvious, 1001. You can see from this also by observation. So number of terms, common difference. So summation, which is Sn equals to n by 2 a plus l, because here we know the last term, a plus l. What is n? 1001 by 2. What is a? 1. What is L? Here it is 1001. So this is 2002 by 2. So we'll get the 1001 the whole square finally after the simplification. So square it, so we'll get this much finally. That is summation of given sequence for odd numbers from 1 to 2001. Okay. Question number 2, second question. The second question is about sum of all numbers, natural numbers lying between 100 and 1000 which are divisible by 5. So here sequence is this 105, It's written between, remember. So 105, 110, between, so last number is 995. You are asked between these two numbers. Between which two numbers? 100 and 1000. So these two numbers are not included. These two numbers are excluded here. So first number is 105, last number is 995. Now again we want the summation. So we need A, which is 105. You need common difference. Common difference is obviously 5. D is 5. Okay. Now how many terms are there? So again use this AN formula, which is A plus N minus 1 into D. You need to know how many terms are there. AN means last term, which is 995. What is A? 105 plus N minus 1 into D. What's the common difference? Which is 5. So just simplify here. So you will get N equals to 179. Just try. I'm not spending much time for this because such things you did in 10th standard also. Okay, so you know N now, you know A, you know common difference. So here required summation, required sum, that is equals to N by 2 first term plus last term. Sum of the all numbers between 100 and 1000 which are multiple of 5 divisible by 5. N you know 179 by 2. A you know what is A, 105, plus L you know what is L, last term 995. Right, you just simplify. So you will get here, I repeat, 105 plus 995, and here total terms 179 by 2. Just simplify, so you will get the required summation here. Fine. For third question, for an arithmetic progression, a1 equals to a equals to 2, you are given. Sum of first term is 2. Sum of the first 5 terms, that is S5, is 1/4. This is given, remember, in the data. Is 1/4 of next 5 terms. Next 5 terms. This is given. Now how to write symbolically, that we need to see. And what is asked in the question? Show that the 20th term is minus 112. So we want this A20, that is minus 112. This is what we want to prove here, 20th term. So you have first term, you need to know what's the common difference. Once you know common difference, you can find A20. What is A20? That is A plus 19D, you know. You know A, you need to know D. So we use this relation, we get D and we place here. Fine, that's all in all about the solution. In every AP question, either you need to use the formula of AN or the formula of SN. Only two things you need to do. Fine. Okay, now let's use this concept. What's the meaning of 1/4 of next 5 terms? That's we want to write symbolically here. So here S5 you know, that is A1 plus A2 plus A3 plus A4 plus A5, that is S5, you know, S5. Next 5 terms. Next 5 terms means what? A6 plus A7 plus A8 plus A9 plus A10. So it is up to 10. You want this. So how do we express that? So this one is fine, S5. Now we want this. Next 5 terms. Sum of the next 5 terms. We want this. So what we do? We add all 10 terms, which is S10 minus, I'll write first 5 terms, that is S5. So you will get the last 5 terms. So this is the last 5 terms summation. Last 5 terms summation. What is the sum of the last 5 terms? Total terms minus first n 5 terms here. Total how many terms are there? 10 terms. A1 to A10, 10 terms minus what I'll do, I'll drop this much summation. I'll drop this much. So you will get the last 5 terms here, A6 to A10. So minus summation of this, that is S5. So I'll place there here. So S5 equals to 1 by 4, S10 minus S5. This is the sum of the next 5 terms. Now simplify. So 4 into S5 equals to S10 minus S5. We need to get the D, as I told you. A you know, which is 2, and that you will get from this. Take this one over here. So 5 into S5 equals to S10. Now just write the formula for both of this. 5 as it is. What is the formula for this? 5 by 2, 2A. A is 2. So this is 4 plus n minus 1, which is 4D, equals to here 10 by 2, 2A. A is 2. So this is 4 plus n minus 1, which is 9D. So let's simplify. 2 will get cancelled. This is 25 into 4. So 100 plus 100D. This is 10 into 4, 40. Plus this is nothing but 90D. So here, what's D from this? You check, it will be minus 6. D will be minus 6. And once we have D, we come back to A20. So A20 equals to, as I told you, A plus 19D. What is the formula for AN? We know A plus n minus 1D. Fine. What is A? That is 2. You know. 19 into, what is D? Minus 6. So you will get the minus 114 plus 2. So you'll get the minus 112. That is A20. Right? That's what you wanted to prove. The important one was this step. The information about the next 5 terms. Fourth question. You are given one AP here. That is minus 6, minus 11 by 2, minus 5, and so on. The question is, how many terms, that is n, are needed to get the summation, that is Sn equals to minus 25. Find n, that is the number of terms for which summation becomes minus 25. So you have information about summation, which is minus 25. You want to get n, so you need to know what is A and D. So clearly A is first term. What is that? Minus 6. D, common difference, term minus previous term. Minus 11 by 2 minus 6. So this will be plus 6. So this is how much? 1 by 2. So D is 1 by 2 here. Half. Fine. So your common difference, you have first term. So we use this now. So using this formula, Sn equals to minus 25. What is Sn? N by 2, 2A. What is A? Minus 6. Plus n minus 1 into D. What is D? Half. Equals to here minus 25. Now we just need to simplify. So we'll get the n. I'll take 2 as the LCM here. So this is n by 2. Minus 12 and 2. Minus 24 plus n minus 1 by 2 equals to minus 25. So here, now we'll just take 4 on the other side. So this is minus 100. This is minus 24n plus n squared minus n. So we are getting quadratic equation. N squared minus 25n plus 100 equals to 0. Plus 100 equals to 0 here. Factorize this. So n minus here 20. N minus 5. These are the two factors. So either n is 20 or 5. Right? Either you have 5 terms or 20 terms, then summation becomes minus 25. It's quite possible because you see the sequence decreases. So somewhere in the sequence, now question is this possible? Either for 5 terms it is summation minus 25 or 20 terms, yes, because you see here sequence decreases. So it decreases somewhere, you will get the 0 and then again it would increase. That's why it is possible. But if you add first 5 terms, summation will be minus 25, or if you add 20 terms, summation will be again minus 25. Fine. Fifth question. For an arithmetic progression, for an AP, you are given pth term. So symbolically, AP equals to 1 upon Q. And qth term, that is AQ equals to 1 upon P. This is what you are given. And what we want to prove? We want to prove this. Let me write here. Sum of the PQ terms, that is SPQ equals to half PQ plus 1. This is what you want. We want this one. So just you need to recall the formula for Sn and we just place the value. Fine. Okay. First, before we get into simplification of this, we write the simplification here. What is AP? Pth term, that is A plus, P minus 1 into D equals to 1 upon Q. What is this? Here AQ, qth term, that is A plus Q minus 1 into D equals to 1 upon P. Fine. So we have these two equations. You can call equation 1 and 2. Now, roughly if you write SQ, what is SQ? We want this. So SQ will be n by 2, that is PQ by 2, 2A plus n minus 1, that is PQ minus 1 into D. So you need A and D in short. So what we do? We just use elimination and we'll find A and D from this. So solving these two equations to get A and D. To get what? A and D, and then just replace in the formula. Fine? Okay. So you take the difference. So directly you will get the D very easily. A plus P minus 1 into D equals to 1 upon Q. Your A plus Q minus 1 into D equals to 1 upon P. I'll just take the difference. So you will get D very easily. Okay. So I'll take D common. You have P minus 1. This is minus Q plus 1. So just check, it is just P minus Q. Minus 1 plus 1 will get cancelled. Okay, what about this? 1 by Q minus 1 upon P. Do the cross multiplication. So we'll get the D from this. P minus Q upon PQ. So P minus Q upon PQ. And this P minus Q here, let me write here P minus Q. So this will get cancelled with this. So from this you will get the common difference, which is 1 upon PQ. The common difference is this. Fine. Got it? Now we put D in one of these two. So we'll get the A. So let me write by 1. I'll write by 1. A equals to 1 by Q minus P minus 1 into D. What is that? 1 by PQ. What I did, just in first equation, I have placed D. Why I'm putting D? Because I want A. We got D, now we want A. So just open the bracket. 1 upon Q as it is here, minus PP will get cancelled. That is 1 upon Q. And this minus will be plus, which is again PQ. So this will get cancelled. So small a is also 1 by PQ. A is 1 by PQ. D is also 1 by PQ. Now we get into what you are asked. What is asked? Sum of the PQ terms. So SPQ. Write the formula for this. PQ by 2 into 2A plus n minus 1, that is PQ minus 1 into D. This is what you are asked. So here, so PQ by 2 as it is, 2 into, what is value of A? That is 1 by PQ. P minus 1 as it is. What's the value of D? Which is 1 by PQ. Take 1 by pq common, it will get cancelled with this. So here we are left with half. This is 2. Take this one common and it will get cancelled with this. Plus p minus 1. So we'll get the half inside the bracket. I'm sorry, here it is pq. Here also pq. pq is there. By mistake I wrote p only. pq minus 1. pq minus 1 plus 1. So pq plus 1. That is the sum of pq terms. That's required sum of the n terms. Fine. So you must have realized in this 4-5 questions everywhere these two formulas are important. An equals to a plus n minus 1 into d, and the other one, that is Sn equals to n by 2 into 2a plus n minus 1 into d. Or you can use n by 2 a plus l. Right? Every question of arithmetic progression always you can do either using this or both. Right? That's what you did in the previous question. In previous question, that's good question. What you did, you wrote the formula for AP, AQ. You have noticed what you required, and then accordingly you just solve these two equations for D and A. So you are getting this and just placing the values.